Okay, in this unit, we are going to go ahead and find a parallelogram based on some equations of lines. So what we're doing in this lesson is we are combining what we learned at the beginning of this session, where we learned how to graph lines. And then we are also applying what we know about parallelograms and the conditions of them, and then also special parallelograms. So let's go ahead and take a look. Our job is to graph the lines and determine the type of quadrilateral formed by the intersecting lines. So let's graph that first line. Y equals negative x minus 1. So my y-intercept is a negative 1, and the slope is also a negative 1. So I go down 1 and then to the right, down 1 and to the right, or I can go up 1 and to the left. So I'm just going to continue plotting as many points. So there is that line. Now I'm going to go ahead and plot y equals x plus 5. So my y-intercept is 5. And the slope is 1. So if I go up 1 to the right, up 1 to the right, or I can go down and to the left. And I'm going to connect those points. Okay, then I'm going to do negative x plus 9, so my y-intercept is a 9. And my slope is a negative, so I'm going to go down 1, over 1 to the right, down 1 to the right, up 1 and to the left. So something like that. And then the last one is x plus 11. So I'm going to start up at 11. And my slope is a positive, so if I go up 1 and to the right, or I can go down 1 and to the left, down 1 and to the left. And there we go. So the quadrilateral I'm talking about is this quadrilateral right in here. And my job is to determine what type of quadrilateral it is. Well, hopefully you can tell that this is a parallelogram, and here's why I know it's a parallelogram. Let's look at the red line I drew. What's the slope of the red line? Well, the slope of my red line is a negative 1. Look at the side opposite. The side opposite is what I graphed in blue. Well, what's the slope of that line? Remember, it's the number in front of x. Well, it's a negative 1. So the slope there is a negative 1, which means that those lines are parallel. Well, now let's look at the black line. So the black line, the slope of the black line is positive 1, because there's a 1 in front of that x. And the side opposite is the green line. And the slope of the green line is 1. So since the slopes are both 1, I know that those lines are parallel. So I've proven that this quadrilateral is a parallelogram. But now I need to determine if it's a square, rectangle, or a rhombus. So is it a square? Is it a rectangle? Or is it a rhombus? Well, let's think about a square. A square is going to have a property from a rectangle and from a rhombus, so we're going to go there last. Let's first talk about a rectangle. We know that in a rectangle it has how many right angles? It has 4 right angles. So if it has right angles, how would I verify in the coordinate plane that I have right angles? Well, we'd have to use the slopes. So if I need 4 right angles for a rectangle, I'm going to use the slopes. Because I know that slopes of right angles or slopes of perpendiculars are opposite reciprocals. Well, we already found the slopes when we proved that it was a parallelogram, so let's take a look. If I look at that red line, so let's take a look at my red line. The slope of that is negative 1. Well, it intersects the green line, which is a slope of 1. Well, another property we know are that if we look at the slopes, if lines are perpendicular, then the product of the slopes would equal -1. That's a property of negative reciprocals or opposite reciprocals. So if we look here, the red line has a slope of -1, and the green line has a slope of 1. So -1 times 1 is -1. Well, that red line also intersects the black line. The slope of the red line is -1, and the slope of the black line is +1. So -1 times 1 is another -1, which means in my picture, I'm going to go ahead and draw right angles in here. Well, I can do the same with the blue line. The blue line intersects the black line and the green line. And if the blue is perpendicular to black, then the slopes would equal -1 when I multiply them. So -1 times 1 is -1. So I know that's the right angle. And then for my blue line, I'm going to go ahead and take -1 times the green line, which is 1. So I get another -1. So I know I have 4 right angles. So I know it's at least a rectangle. So now, just by looking at my picture, hopefully you can tell that the sides are not congruent. All 4 of those sides are not congruent. So even though I said that it's a rectangle, it cannot be a square, and it could not be a rhombus. So the question is, how would you determine, based on my picture, what the lengths of all 4 sides were? Well, hopefully you're thinking in your head we would have to use the distance formula. And you're right. We would have to use the distance formula. Kind of like we did when we found the perimeter of our polygons when we were graphed in a coordinate plane. You would have to go ahead and find the distance. Let's label this as A, B, C, and D. You would have to find the distance of AB and show that it's congruent to DC. Then you would find the distance of CB, and CB should not be the same as AB, because if it was the same, then we know that we would have a square. So there's just one example of how we can go ahead and take lines and determine what type of quadrilateral is formed by the intersection. Great job!